All right, in this first video today, we're going to take a look at the quotient property, which is really one way that we divide radicals, or anytime that you have a fraction that includes radicals, square roots. So one of the items we looked at earlier this unit was that the radicand can't have any perfect square factors. All right, so simplifying a square root means that you take those perfect square factors out. That's what we've been working on. The second piece here is that the radicand has no fractions. So if you look at the item on the left, you see that you have the square root of 5/9. And we never want to leave anything with a fraction inside a square root symbol. Okay, so we never want to leave it as a square root of a fraction. Instead, what we're going to look at today is how to divide radicals, how to use this quotient property to simplify something like that. So here's the quotient property for our lesson today. The quotient property basically says that if you have the square root of a fraction, like we see on the left side over here, the square root of x over y, notice the fraction is all inside or underneath that square root symbol. It's going to be the exact same thing as if we take the numerator and the denominator of that fraction and basically split the square root into two square roots. So the square root of x divided by the square root of y is the same thing as the square root of x over y. Now, the conditions over here have to be met that x has to be greater than or equal to 0, meaning it can't be a negative number. And then y has to be greater than 0, again, meaning it can't be a negative number, because we can't take the square root of a negative number. Okay, at least not yet. So with this quotient property, let's see how it works. You might see examples like this where we are taking the square root of one number and dividing it by the square root of another number. So think of this like dividing radicals. Well, our property, our quotient property, allows us to actually start. In this case, we're starting with what's on the right-hand side, and we're going to move it into this other form. So we're going to take the numerator and the denominator and put it together to make it one fraction. So since we had 24 as our numerator up here and 6 in the denominator down here, each having a square root, it's going to be the exact same value as if I put those two numbers together as a fraction. The advantage to doing that is we can divide 24 by 6. 24 divided by 6 is exactly 4. So this just becomes the square root of 4. And you might remember 4 is a perfect square. It actually just equals 2. So being able to use this quotient property allowed us to simplify this expression down to its actual true value of just 2. Now here's another one, but in this one, we're starting with a fraction underneath that radical sign. The fraction is the radicand. So in this case, I can't divide 64 by 9 and simplify what's inside the radical. So instead, let's go ahead and split it up. Let's keep the 64 in the numerator, the 9 in the denominator, and apply the square root to both numbers. That's our quotient property working in the other direction. We're splitting into two radicals instead of combining them into one radical. The advantage here is we have two perfect squares in the numerator and the denominator. The square root of 64, of course, is 8 because 8 times 8 is 64. And in the denominator, the square root of 9 is 3 because 3 times 3 is 9. And we get 8/3, which we can't reduce any further. I mean, you could write it as a mixed number, but we don't have to. And it doesn't divide out evenly, so I wouldn't want to write it as a decimal. We just leave it as 8/3. Let's look at one more way that we can, one more example of how we're using that quotient rule. So in this one, we start with, well, let's see, square root on the top, square root on the bottom. Well, neither one of those are perfect squares. So instead, let's go ahead and combine them and see if that's helpful. We take the numerator and the denominator and apply it into one square root with one fraction in the inside of it, and we get the square root of 24/3. Well, 24 divided by 3 is 8, so that's going to be the square root of 8. And 8's not a perfect square. Remember, it's not like dividing by 2, so it doesn't equal 4. 4 times 4 is 16. It would be like 2 point something times itself to equal 8. So we don't want to get a decimal answer. Instead, we simplify any radical by taking out perfect square factors. So this is a review from day one of simplifying our radicals. We're trying to figure out, what two numbers multiply up to 8, which includes a perfect square. And we know that 2 times 4 equals 8. And 4 happens to be a perfect square, right? The square root of 4 is exactly 2. And we just bring the other part down and we get 2 times the square root of 2 as our answer. So the square root of 24 divided by the square root of 3 ends up being 2 square root 2. Oops, one more. Sorry, I forgot about the one with the variable. In this one, we recognize that we have one square root where we have a numerator and a denominator inside the radicand. So it looks like let's try using our quotient rule by splitting into 2 radicals where the numerator stays on the top, denominator stays on the bottom, and see if that helps us. Well, let's see, on the top part in the numerator, the square root of 20x cubed, that's not a perfect square, but I think we could actually simplify that. I'm going to do that down here, 20x cubed. Let's see, that would be, 20 can be written as 4 times 5. And then we have x cubed, x times x times x. So in terms of simplifying our perfect square factors, remember that if a number is a perfect square, it can be simplified. Or if there happens to be 2 of the same factor, that also represents a perfect square, which can be simplified out and placed in front of the radical. So the leftover parts were the 5 and the other x. So our numerator actually becomes 2x times the square root of 5x. That's how that's simplified out. And the denominator was the square root of 64. Well, that's just 8. So it might look like we're done, but we're actually not quite done yet because there is something we can do to reduce or simplify the non-radical parts within a fraction. If you have a common factor of those parts, the non-radical parts, we can basically reduce the fraction. That's like, what can I divide out of 2x and 8? I can actually divide them both by 2. So we need to do that. So I'm just going to put a little divide by 2 up here. And our final answer then, after we divide those by 2, let's see, 2x divided by 2 is just 1x, or simply just x. And I bring the non-radical part with. Notice I don't divide that by 2, just the coefficient part. And then the denominator, 8 divided by 2 is 4. So I have x times the square root of 5x all over 4 as my simplified form for this last one.